As you're writing down your aim, you're going to see that our aim today is that we're going to use the additive inverse to solve one-step equations. Now, you have all learned how to solve one-step equations before. However, at some point in time, probably close to testing last year, a lot of you got into your head that you didn't have to solve equations anymore. You could just guess and check, which is an excellent strategy for test taking. However, it is not an excellent strategy for actually knowing how to solve equations. So somewhere along the lines, you guys stopped learning how to solve equations. You let that just run out of your brain, and you started to just throw in a number. All right, did that number work? No, it didn't. Let me throw in another number. Did that number work? Unfortunately, once you get past these very easy whole number problems, that strategy is not going to work nearly as well anymore. So today we're going to be spending some time working on some problems that you are not going to be able to guess and check, because I'm giving you harder problems with more difficult numbers, but what you learned is the same. So we're going to go back through those basic details about how to solve equations and why we do what we do. All right? So previously you have been taught how to represent additions on a number line. So what we see here is we see the addition of 5 plus negative 3. So we start with an addition of 5. That means we're adding 5. We're moving forward 5 units. So I get this arrow to move forward 5 units. And adding negative 3, this is this arrow I have coming backwards. 5 plus negative 3. And we see that takes us to line up at 2. This makes sense. 5 plus negative 3 is 2. Okay? So we can represent an addition by an arrow moving forward. We can represent the addition of a negative by an arrow moving backwards. We're going to use this same idea to help represent an equation that has additions in it. So we have this situation where I started an unknown place. I'm not going to tell you where that place is, but I'm going to tell you that in order to get to that place, I moved 5 steps forward. And I'm going to end up at 2. So first question is, how can I represent this as an equation? I started an unknown place, I move forward 5 steps, and I end up at 2. Sunny. So I'm starting in an unknown place, we'll call it n in this case. We're moving forward 5 steps, plus 5 steps, and we're ending up at 2. All right, so this is an equation. How can I represent this equation on a number line? So we know that we can represent the addition with a forward moving arrow. So what I want you to do is I want you to show me this situation on the number line. Starting at the unknown place, moving 5 steps forward, and ending up at 2. Show me that on the number line. All right, I'm going to check in with Cheston because I saw something I really liked on Cheston's work. Now Cheston, I saw you do this. Let me just kind of copy your work. 1, 2, 3, 4, 5. So I see that you started at this unknown place. You started at negative 3. How did you know to start at negative 3? Wait, 2 minus 5? I don't see any minuses up here. So what Cheston is doing is he's not even thinking about it, but he's doing an inverse operation. He's saying, I know that in order to undo those 5 steps that we move forward, all I have to do is go back from where we came. So solving equations is really just a matter of tracing your steps backwards. So the steps that we took was 5 steps forward. So to figure out where we started, we trace our steps backwards 5 steps backwards. So essentially, what he did was he said, I'm starting at 2, because that's where I ended. I'm taking 5 steps backwards to undo the 5 steps forwards, and ending up at negative 3. So Cheston knew to start the arrow at negative 3 because in his brain, he did an inverse operation. And it's the same thing here. So we can see that represented up here. And we can see the same thing happen solving the equation. So we have x plus 5 is equal to negative 2. Well, that 5 steps backwards, that's the same thing as adding what? Kyrie? Negative 5. So one thing that you definitely remember from your 5th grade equation solving is that it's like a balance. Anything you do to one side of the equation, you have to do to the other. So I had added a negative 5 to do that inverse operation to one side of the equation. I'm going to do the same thing on the other. Now, 5 plus negative 5. What property is that using? Five plus negative 5. What property is that using? Leslie? Additive inverse. Now, it's interesting that she said additive identity because that actually allows us to move to our next step. We have 5 plus negative 5. Those add up to 0, which is why they're inverses of each other. And x plus 0, which is this kind of unsaid step in between, x plus 0 is equal to x. So that goes back to that idea that we talked about last unit. Every time we use the inverse property, we also end up with the identity property. This x plus 0 is just x. 2 plus negative 3 is, 2 plus negative 5 is negative 3. So when we're solving equations, we know what to do to both sides of the equation because we're always going to be retracing our steps. And we know that we need to do the same thing to both sides of the equations. Those are just basically the rules of equation solving. Retrace your steps, and do the same thing to both sides of the equation. Simple. Yes, Jalen?
You can make a key point from that.
Jalen wants to hop up and make that key point. I think he's absolutely right. So key point number 1, always retrace your steps using inverse operations. And 2, the other point there was always do the same thing to both sides of the equation. That doesn't look like the word always. Let's try again. Always do the same thing to both sides of the equations. Now, that's our lesson in a nutshell. Now, there are some small details that we need to pick up about how we're going to do this, and some small things that we may see here and there that we need to know what to do to deal with it, but that's equation solving. Honestly, I should be able to give you the most difficult equation in the world, and you would know how to solve it because it would be the same basic thing. Okay, well, what was the last thing that was done here? All right, let's undo that by doing the inverse operation. All right, what was the next thing that was done? We'll inverse that, and so on, and so on, and so on. This is basic equation solving. If you know that, you know how to solve equations. So let's look at this situation here. I start with an unknown. I start in an unknown place. I walked backwards 3 steps and ended up at -9. Somebody write an equation for that one. I want an equation, just like we wrote over here for this one. N plus 5 is equal to 2. For this situation, I started in an unknown place. I walked backwards 3 steps. I ended up at -9. Kevin, what's the equation that you wrote?
N plus negative
Yep. Oops, not plus.
Minus.
Equals -9. Now, I hear Jalen saying he wanted to write this as n minus 3 is equal to -9. Well, these statements are the same because Kevin has just taken the step already to leaf chain switch. It's not a big deal. But that's something that we have to know when we're doing our work. When we see a subtraction, the first thing we're going to do is what? Leaf chain switch. All right, so let's go ahead and draw the situation. We're going to draw that situation. I know I'm ending up at -9. So in my head, I'm thinking, they walked backwards 3 steps to get there. So to figure out where I started from, my inverse operation is going to be to actually move 3 steps forward.
Oh, yeah.
Because we went backward, to untrace that, I need to go forward. That tells me that I started at, my n was at 6. And I'm going to check that by saying, if I walk backwards 3 steps, 1, 2, 3, am I going to get to -9? Absolutely. Okay? So when it comes to solving this equation, I'm looking at my inverse operation here. My additive inverse, I want to add the opposite of that -3, so I'm going to add what to both sides? Viviana? +3. -9 plus +3. -3 plus +3, that adds up to 0. So notice the step that I do when I see my 2 additive inverses. I show that they add up to 0 with this little arrow and a 0. You must show that piece of work, or you can show an extra step in between of n plus 0 is equal to -9 plus 3. Your choice. You can choose the arrow with the 0, or you can choose this step of work. It doesn't matter to me, but both of them prove to me that you understand what happens in this inverse operation. All right, so n plus 0 is n. -9 plus 3, opposite sign subtract. 6, take the sign of the larger number, negative. We can solve equations. You can do it, all right? So I want to flip on over to where your together time would normally start. We've got a handful more of teacher time problems. That's just for me to make some specific points. So the reasons I'm doing these problems is really more to hammer home a couple of points, as well as to make sure that we are 100% on the same page as to what the work should look like. Now, I've given you these frame problems over here on the left-hand side where all you have to do is fill in the blanks. So this first one, we have x plus -2.5 plus 1.3. And on the next line, we're doing the inverse operation. What is the inverse operation? What am I adding to both sides of this equation? What goes in these blanks? Maria? Positive or negative? Positive, because we already have the negative. If I add 2 negatives together, I end up adding them. They don't cancel out. -2.5 plus 2.5, I'm going to show that that adds up to 0, or alternatively, you could put in the step that you know x plus 0 is going to be equal here. Looking at the right-hand side of the equation, 1.3 plus 2.5 is 3.8. Next one. This one's got fractions in it. Is it going to be any different with fractions? No, it is not. So I have x plus 1/3 is equal to -3/10. What am I going to add to both sides? Craven. -1/3. So we had a positive. We're adding a negative. Adding a -1/3 to both sides. 1/3 plus -1/3, Leslie, adds up to what? Yep, so we can show that with the arrow, or you can choose the x plus 0 way. Either way. And I have -3/10 plus -1/3. Now, this is what makes things tricky about fractions, is we have to go ahead and make sure that we do have common denominators, just like always. Oops, that's 10.
It's 130.
It was 30.
So I have negative 9 thirtieths plus negative 10 thirtieths.
Negative 1930.
So Judea has like signs added here and taken the sign of the larger number and gotten negative 19 thirtieths. Sorry, negative.
1930.
Go. So this is one of the key details when it comes down to this. And this is why you notice I write my work in the line. A lot of you, when you see a problem like maybe this one over here, you're going to want to write minus 0.35 and minus 0.35 over here. I think when a lot of you do that, you miss the like signs add and different signs subtract things. That's why we write things in the line. This will not be acceptable work. You will get your problem marked incorrectly if you show your work not in the line. All right? Looking over at this one, it says x minus 4.25 is equal to negative 3.05. Now there's a step here before we do the inverse operation. What do we need to do before we do the inverse operation here? Alvaro. Leaf chain switch. So here I'm just rewriting it after the leaf chain switch. And that tells me now that I need to add what to both sides? What is my additive inverse that I'm adding to both sides, Emmanuel?
Positive 4.25.
Positive 4.25. Negative 4.25 plus positive 4.25. 0. And here I have negative 3.05 plus positive 4.25. Everybody, like signs add or different signs subtract? Different signs subtract. And I hear Carson focusing in on the next part, which is also very important, taking the sign of the larger number. Our larger number here was positive, so our answer is going to be positive. So I get 1.20, and we said that's supposed to be positive. All right, so these are what I call frame problems because I'm giving you the frame of the work. All you've got to do is fill in the blanks. I also call them training wheel problems because it does half of the work for you. All you've got to do is fill in the blanks. Now here, I'm giving you the problems, and I'm saying now you've got to figure out all of that work on your own. X minus 205 is equal to negative 103. Tracy, what is the first thing I need to do with this problem? Leaf chain switch. I'm actually going to rewrite this as a leaf chain switch. The reason why I do this is because when I don't rewrite it, I sometimes have a tendency to lose those negatives after the leaf chain switches. What is the inverse operation I need to do with this particular problem? Judea.
X plus negative 0.5. Oh, no, wait. Put it in parentheses and then plus positive 0.5.
So she's putting it in parentheses. You don't necessarily have to put it in parentheses. The reason I do that when I write out the problems is just so it's more clear that that's a negative sign and not a subtraction. But she knows she has to add the opposite, which is a positive 205. So negative 103 plus 205. Negative 205 plus positive 205 adds up to 0. Negative 103 plus 205. Everybody, like signs add or different signs subtract? So I'm going to subtract 205 minus 103. It's going to be 102. Take the sign of the larger number. Carson, the larger number was? For negative. In this addition, is it positive or negative?
Positive.
Positive. So our sign of our larger number is positive. So this is positive 102. Okay, let's look at the next one. X plus 0.35 is equal to negative 1.03. No leaf chain switch here to do, so all I have to do is my additive inverse. Emmanuel, what is my additive inverse here?
Negative 2.
Yeah, add a opposite, which is negative. Oops. Negative 0.35. Negative 1.03 plus negative 0.35. Everybody, like signs add or different signs subtract? Like signs add. Good. So I add them up and I get 1.38 and I box in my answer. Really? Just Alvaro? Just Alvaro? Yeah, take the sign of the larger number. All right? I'm not going to do the fraction one at the end because we are running a little bit short on time today, so we're going to move on to our together time.